Hello and welcome. Today we're going to continue our look at the properties of exponentials, and we'll do that here first with this opening exercise. You should have your unbounded student version of this PDF in front of you. It's going to look just like mine with the blanks and stuff, and we'll fill those in today as part of our notes. So let's get started here. The opening exercise asks us to write each exponent as a radical, then use the definition and properties of radicals to write that expression as an integer. Okay, so let's do that. So first we're supposed to write each exponent as a radical. So 1/2 is for both of these, so that means it's going to be the square root of 7 times the square root of 7. Using our properties of radicals, since we have the same square root here, we can then just write this as square root of 7 times 7, or in other words, the square root of 7 squared. Okay? When you simplify that, we get just 7. Okay, let's try here with the 3's. Since we have 3 for our denominators, that means we are talking about cube roots. So it's the cube root of 3 times the cube root of 3 times the cube root of 3. Which, because again, they're all underneath the cube root, we can multiply them, and it'll be equal to the cube root of 3 times 3 times 3, or the cube root of 27. Or the cube root, I should say, of 3 cubed, which will give us 3. Okay, let's continue here. 1/2 and 1/2, so it's going to be the square root of 12 times the square root of 3. And then, since this is the same, they're both underneath the square root, we can do 12 times 3 underneath the square root, which is the square root of 36. And what's the square root of 36? 6. Okay, here we have a power raised to another power. So how can we simplify these two things? We would do what? We would multiply. So we're going to get 64 to the 1/6 power, which is the same thing as saying 64 6th root of 64. What is the 6th root of 64? 2. Okay. For these next examples, 1, 2, and 3, we're going to write each expression in the form b to the m over n for positive real numbers b and integers m and n with n greater than 0 by applying the properties of radicals and the definition of the nth root. Okay, so here they want us to use properties of radicals. So we could do this by rewriting this as the 4th root of b times the 4th root of b, which would give us 4th root of b times b, or in other words, the 4th root of b squared. But we want to express it in this form, so I need to rewrite this as b to the 2 over 4, right? The 4th root of b squared would be 4th root there in the denominator, right? The 4 and the 2 in the numerator. And that 2/4 can simplify to b to the 1/2. And yes, you can simplify a fraction and an exponent, just like you would a fraction elsewhere. Okay, an alternative way to do this is just to use our exponent properties, of course. Since we're multiplying with the same base, we can just add the exponents. So it's 1/4 plus 1/4, or b to the 2/4, which would simplify to 1/2. So again, you can see here they're kind of leading us through a murkier path here, which is we could just use our exponent properties and stuff. So ask your teacher which way they would like you to do this. Okay, so again, similar situation here. We can rewrite this as the cube root of b times the cube root of b to the 4th. And again, we get that because 3 in the denominator but 4 in the numerator there, which allows us, because they're both underneath the cube root, to do b to the 5th. Well, I should do b times b to the 4th, which becomes the cube root of b to the 5th when we multiply there, which we can then rewrite in exponential form as b to the 5/3. Again, because we have an exponent of 5, cube root, so the 3 would go in the denominator, 5 in the numerator. Okay? And in this one, okay, if we rewrite these as radicals, we're going to run into a problem here because we have the 5th root of b and the 4th root of b from the b to the 1/5 and the b to the 3/4 there. They don't match up, and so we can't bring these two b's together. So what do? Well, we'll use our exponent properties here instead. That says that if you multiply, right, and you have the same base, you do what with the exponents? We should add them. So it's b to the 1/5 plus 3/4 power. Now we can simplify this. Let's do that side work down here. To add fractions, you need common denominators, right? So we have a 5 and a 4 here. So what is the common denominator going to be here? What's the least common denominator going to be? Well, the multiples of 5 are 5, 10, 15, 20. Multiples of 4 are 4, 8, 12, 16, 20, and aha, we can see they both have 20 as a multiple. So we'll multiply this fraction by 4 over 4. We'll multiply this fraction by 5 over 5. Multiplying by 4 over 4, right, does not change the value. It's multiplied by 1. Multiplying by 5 over 5 does not change the value. It's multiplied by 1. So we get 4 over 20 plus 15 over 20, which gives us 19 over 20. So this equals b to the 19 over 20. Okay, and we'll stop there and see you in the next video.